Hello, AE7TO here, and I'm going to describe and demonstrate a method for HF band selection on difficult paths for emergency communications purposes. What you see on your screen right now is a line of sight profile between a test transmitter located here and a test receiver located here about 30 kilometers north. As you can also see on this profile, there's a very large hill mass just north of the transmitter that makes this a particularly difficult path for communications. It certainly wouldn't work for UHF or VHF unless you could convince somebody to set an emergency repeater up on that hill or some nearby hill. And it's also difficult for HF because it's so close in that it's inside the skip distance on most bands at most times. So how do you, in an emergency scenario where you set up two portable stations, some relatively short distance apart but too far for line of sight, how do you decide what band to operate on? Well, one thing that we often do is use HF propagation prediction software, and we punch in the parameters and we come back with predictions as to what bands are going to work at what times of day given the current solar conditions. Here you have a prediction for today on that path, and it's pretty cut and dried. It looks like the only band with any chance of success is going to be the 80-meter band. In most cases, for more reasonable distances, say 1 to 200 miles, you're going to get a very different chart where the band that's going to work is going to vary throughout the day. And there's likely to be a requirement for some judgment on the part of the operators as to which band to use at a given time. So in that scenario, the challenge you face is you can't communicate because, let's say it's a regional disaster where all the infrastructure is down. There's no internet, there's no cell phone, there's no landlines, and you haven't got the radio link up yet. So how do you coordinate the band selection, and for that matter the operating mode, the software you're going to use, or the voice mode that you're going to use at each end when you can't communicate in the first place? So that's really the purpose of what I'm going to demonstrate, is to assist with ad hoc band selection between two point-to-point links over HF. Before I get there, another piece of software that's extremely useful is this online real-time NVIS prediction map, and it shows, and it's consistent with the vocab prediction, that the highest frequency that's likely to work for NVIS is about 4 megahertz, so that also points to the 80-meter band. But again, the scenario we're talking about, you can't get to the internet, and even if one end or the other could get to the internet, in most cases you're going to have a lot less clarity about what frequency you're going to want to use. So let's go and look at the setups at each end in order to illustrate how this works. This is the receive or north end. We have, first of all, a receiver is an SDR Play RSP1 software-defined radio. It is connected to a 57-foot end-fed random wire antenna, and it is controlled using HD SDR software to interface to the SDR, and CAT control of HD SDR is via Ham Radio Deluxe, and then WSJT-X software is the beaconing software that we're using in order to explore this path and make our choice of bands. So the role of this station again is whisper listener. Here is the HD SDR software showing the received signal. Not much going on at the moment, at least not visibly. Right now we're monitoring the 80-meter band. And here is the WSJT-X interface, and I see that I just received a beacon from my transmitter. The signal noise ratio was minus 24 dB, and again 80-meter band. This distance is based on grid to grid, so it's not as accurate as the path prediction that I showed you a minute ago. It's more like 30 kilometers, not 50. But what's interesting as you look in this herd list is we are hearing other stations on other bands, but those stations are beyond the skip distance. So the only signals that I'm receiving on this path between my transmitter and my receiver are on the 80 meter band. Just now at minus 24 dB, at 1636 Zulu, minus 22 dB, 1612 Zulu, minus 22 dB. And then as I go back earlier in the morning, it actually peaked out around minus 19 dB here at 1602, and again here at 1542. And then even earlier in the morning, it was a little weaker at minus 22 again. So what we're seeing here as the sun rises is that the conditions improved a bit for the 80 meter band, and now they're starting to fall off again as more and more of the upper atmosphere is ionized. So the beacon is doing exactly what it's supposed to. It's transmitting, and the receiver is receiving and then judging the signal noise ratio. And because I have band hopping enabled at both ends, and that's really the key learning point here, is to enable band hopping in Whisper. Both the transmitter and the receiver are hopping around according to a standardized schedule, so that whenever the transmitter is transmitting on the 80 meter band, the receiver is also listening on that band. And that way we can be assured that all of the bands will be tested, and any of them that will actually work under the current conditions, you'll get a received signal report for the station you care about, and you'll be able to look at the signal noise ratio and make your choice of which one band to use. Now, if we had more than just the 80 meter band received, then you may have to make a decision, but it should be something of a no-brainer, because you just look at the SNRs and then make your choice accordingly. So that's the receive end. Let's look at the transmit end. This is the transmitter here. You can see that right now I'm transmitting on the 40 meter band. Says right here transmitting. Putting out about 4 watts on that band. This is an MFJ 929 auto tuner. I have trained it on each of the bands and stored those parameters in memory, so that whenever I do a band switch, it very quickly switches in the correct inductance and capacitance in order to match the antenna at that frequency. Transmission just completed, so I'm no longer sending. I did just switch to the 30 meter band, and I'm now transmitting on that band. Because it's higher in frequency, my output power is down to about 3 watts. And if I go back to my receiver, I will probably find that I still can't receive. Yep, sure enough, I still can't receive the 40 meter band 30 miles to the north. So this is still the only game in town, although it's getting weaker, and it may be that in a little while not even that band will work. But at least I was able to see, using this approach, that for a while I did have a path that was viable on the 80 meter band. Going back to the transmitter, the specifics at this end, I've got an IC735 transmitter, and this little tool right here I simply use to power it on and off. It's a homebrew piece of software that turns the radio on and off and also switches antennas whenever needed. For CAT control, I simply configured WSJT-X to use the IC735 settings. That's my COM port, all the usual settings there. My interface requires DTR for power, and for push to talk you have to use the RTS line, because that older radio can't do CAT control of push to talk. If I click this button, I can verify that I do have CAT control, and I do. So everything is working for CAT control by WSJT-X of this radio. Some other settings that are worth noting, on my transmit end, I've set transmit percent to 50%. You could go higher or lower that depending on your whims. Most importantly, band hopping has to be selected, and you also have to go into your schedule and decide what bands you're going to be interested in transmitting on. I've selected the 80, 40, and 30 meter bands only, and I've told it to hop on those all day. That's what the rows are, is what time of day to use which band. I've also told it to tune on each band, which means every time it does a band switch, it sends out an unmodulated tone briefly on that band in order to tell your auto tuner to switch in the correct settings for that particular band. If you go into the help, online help for WSJT-X, and you locate the band hopping information somewhere in here. There it is. This is the band hopping section, and it shows how to configure this, and most importantly, this is the schedule for band hopping. So both the transmitter and the receiver are going to hop around according to this schedule. And for time slots that don't have a preferred band, then each radio at each end will make a random choice from the other bands in order to decide what to listen to. But the ones that matter to us are the prearranged preferred frequencies, because those are the ones where your receiver and transmitter are going to coordinate their hop, and then if there's a path, you'll see it show up as a received signal. Let me go back to the receiver and talk about the settings at that end. I have at the receive end HD SDR talking to my SDR play, and I've enabled cat control. I don't care about the push to talk activation pin. Baud rate I've set to 9600. The port, what I'm using instead of a physical port is a virtual null modem cable, and my SDR is at the COM13 end of the virtual null modem cable, and then my cat control software is going to connect to COM14, and that way I can use the cat control software to control my SDR. For cat control at this end, I'm using Ham Radio Deluxe, and when you look at the connection settings for that, it matches mostly what I've got at the SDR end. You have to use, for HD SDR, you have to configure it as a Kenwood. I typically use the TS50S as the radio type, and again, COM14 is the cat control end, software end of the virtual null modem cable. And I am unclear as to why the baud rate is set to 4800 in the cat control software. I do know that the virtual null modem cable is capable of auto switching, so it doesn't probably much matter what baud rate I select. And then WSJT-X is configured at this end. Instead of connecting directly to the Kenwood radio emulation on HD SDR, it connects via Ham Radio Deluxe, and the reason for that is when I connected it directly, WSJT-X had a lot of trouble maintaining connectivity with the HD SDR virtual radio, so it just worked much more smoothly to set up HRD as middleware between the receiver and the cat control. And that pretty well summarizes the setup. Again, the point of all this is you need a way, when you have a point-to-point HF link, you need a way to choose the operating band, and just as importantly, you need a way to coordinate that band selection at both ends of the link when you can't communicate back and forth because you don't have the link up. And this mechanism assumes that you're going to set up a SDR receiver at both ends as a beacon receiver. You might want to use a Raspberry Pi or inexpensive laptop, but the bottom line is you set up a receiver at both ends. You have a transmitter at each end that's going to send out beacons periodically. Right now, this one is transmitting at about 5 watts on the 80 meter band. So with any luck, in a moment, we're going to see it received at this end unless conditions have deteriorated to the point where it's not going to work anymore. With that kind of setup, with receivers at both ends, The operators simply look at the received beacons. They look for the one they care about, and in this case it was 80 meters. That's the only one that works. If we had more than one, we'd look at the SNR and choose the one with the best SNR. But once we see that beacon, we go ahead and switch to that frequency and attempt to establish initial contact, probably using a weak signal mode software like, say, Thor or FS8 call, or I guess it's JS8 call, or Olivia, something like that, FSQ perhaps, some weak signal software, because you're likely to have difficulty otherwise. And I see the signal was received, still the 80 meter band. It's improved a little bit now. Instead of -24, it's -20 dB, but we still do have a path on the 80 meter band only. And really the key is that the software developers for WSJT-X had the foresight to put this band hopping option in here, so that in an automated way receivers at both ends can continue to scan the channels, and then if your operating frequency stops working, you can go back, look at your beacons, and figure out what to switch to in order to reestablish contact. And you don't need an order wire or a cell phone or internet in order to coordinate those switches. You just look for the best band under the current conditions. You do, of course, need to have SOPs in situations where, for example, you have two different bands, both have comparable SNRs. Which one are you going to choose? You have to decide by SOP which piece of software or which operating mode you're going to use to attempt to establish that initial contact. Of course, you can coordinate switches to other modes once you've got that initial contact. So there are many other details to work out, but the key point of all this is that this whisper mode beaconing and band hopping is a great way to explore propagation conditions, not just globally, so you can figure out who you can talk to around the world, but in an emergency situation where you need a point-to-point link, you can use it to figure out what band to use for that link. That's all. I'll probably put some additional notes in the video text below, and thank you for listening.